Math 1314, confidence intervals. Estimating one population proportion. In the previous video, we talked about mosquitoes, and I threw an interval up there, and I said, we'll see where it comes from later. Well, later is now. But before we jump into that, I do want to make one quick point. In any problem, if you are asked to estimate something, that is a key word that you are going to build a confidence interval. Later in the course, problems won't say make a confidence interval or calculate a confidence interval. They will say estimate at a certain confidence level, like estimate at 95% confidence the value of P. So again, if you ever see the word estimate, you're probably going to build a confidence interval. Another dead giveaway is you'll be given a confidence level like this one. All right, so if you'll notice that I kind of took this out of context and just extracted the information. That's going to be a very important skill to have in this class, to be able to read past the word problem in the specific context and extract the information necessary to calculate the requested information. Then at the end, you can put the answer back in the context of the problem. From the previous example, we were given a sample size of n equals 1,000. And we were also given information to calculate p hat, the percent of the sample that has a characteristic, or the proportion of the sample, 40 out of 1,000, which is equal to 0.04, or as a percentage, 4%. Now we're actually going to calculate the 95% confidence interval for p. Now remember, anytime you make a confidence interval, you are making an interval of values to estimate the population version of what your sample measured. So if our sample were measuring a mean, then this would be population mean. In other words, if this were x bar, this would be mu. More on that later. All right, so how do you build a confidence interval? In this class, there are going to be many types of problems where I give you a how-to list, how to do this, how to do that, so that you can see that most of the stuff that we do is very objective. Grab this information, process it this way, spit out a result. Here's the first of many such lists. This list is simply titled, How to Build a Confidence Interval for P. How to build a confidence interval for P. All confidence intervals can be built in 4 steps. The idea of the 4 steps is always the same. What changes is either the specific formula that you use or the distribution table. We're about to meet the z-chart. Step number 1. Using the confidence level, calculate a z-score. Calculate a z-score. Now, how do we do that? Well, it's driven by a picture, a bell curve. We didn't get into the central limit theorem and everything that says what we're doing is centered around a bell curve, but it is, so we're going to take advantage of that. The way that you use the confidence level, so this is step number 1, is you sketch a standard normal distribution. And remember, a standard normal distribution means that the mean is 0, the standard deviation is 1, and we get to use the z-chart. But what the confidence level represents is the center area of a standard normal distribution curve. In other words, we're going to cut off the middle and say that this is 95% of the area. That's what you do with the confidence level. You park it in the middle of the bell curve, and in this case, it's a standard normal distribution. In other words, a z-curve. And we need to find the z-scores that cut these off. Well, this is a skill that we did in week 1. So just a reminder, the z-chart tells you areas to the left of a z-score. I'm not going to get a z-chart out here, but the z's are along the edges. For the digits to the left and right of the decimal are in the left column. The second decimal digit is on the top. you find the intersection of the row and the column, and that tells you the area to the left of that z-score. So we need to pick a z and find its left area. All I know is a middle area, but we've played this game as well. We can find each individual tail's area by capitalizing on two things about this curve. Number one, the total area is 100%. And number two, symmetry. These two tails have the same areas. So to calculate the area of an individual tail, well, let's just do it this way. Together, the two tails are 100% minus 95%, which of course is 5%. But because of the symmetry of the picture, one tail is half of 5%, so 5% over 2, which is 2.5%. And since we're going to be using the z-chart backwards because we have an area and we want a z, we need to think of this as a 4-digit decimal. As a decimal, it would be 0.025, but because the areas in the middle of the z-chart have 4 digits, we're going to stick a 0 on there. Now, if we go look this up, we are finding the z that has that area to the left of it. So if we look up 0.025 in the chart, we're finding this z. So using the z-chart, so I hope you've done the homework from the previous week. Using the z-chart, we get z equals negative 1.96. So guess what the other z is? Based on symmetry, it's 1.96. So there's actually two z-scores. So which one do we need? Actually, it doesn't matter. You can use one or you can use the other. I usually just write down the positive one. And the reason we only need one of them is at the end, when we do the margin of error, we will both add and subtract. So we're going to end up using both of them anyway. But for now, I'm just going to use the positive one. So the answer to this is going to be z equals 1.96. So let's just document over here the answer to the first part of this process. Z equals 1.96. All right, so that's step number one. Step number two is to calculate the standard error. Now, this is a formula, so I will go ahead and give you the formula. The formula for the standard error here, remember the variable for standard error is a capital SE, is a tall square root, and it's kind of long. It's tall because there's a fraction inside of it, and the denominator of that fraction is just the sample size n. The numerator of the fraction is a multiplication problem. The first part of it is p hat, which we have, times, in parentheses, 1 minus p hat. This is not a difficult formula to set up, but being able to put it in your calculator is critical. If you have trouble putting this into your calculator, in fact, if you're watching this video, when I get to that point, I recommend you put it in your calculator, and if you don't get the same answer that I do, contact me, we'll set up a Zoom session, and if you're in my class, if you're some random YouTuber, just drop a message down below, and I'll help you use your calculator to figure out how to put that in. All right, so step number two, calculate the standard error. And by the way, you'll be given this formula, you won't have to memorize it if you're taking my class. Can't speak for your other professors if you're someone else. All right, so our standard error is going to be the square root of a fraction whose denominator is the sample size, so 1,000, and whose numerator is a multiplication problem, the first part of which is the p hat from our sample, 0.04, times 1 minus that. Now, if you want to, you can go ahead and execute the subtraction problem so that you don't have the parentheses. 0.04 times 0.96. You know, it's this reason why I like putting zeros in front of decimals, because this looks messy. Or you could just put parentheses around each one of these to imply multiplication. However you want to write it is up to you. By the way, do you know what the 0.96 represents? Think about it. The 0.04 was the percent of the mosquitoes in the sample that did have the West Nile virus. The 0.96 represents the 96% that don't. So really, This is the percent that have the characteristic in a sample, and this is the percent that don't have that characteristic. All right, so all this goes into a calculator. And again, if you need some assistance putting this in a calculator, you ask somebody. If you're in my class, you contact me. You probably have my cell phone number. If you're in somebody else's class, then ask them. But the worst thing you can do at this point is not know how to put this in your calculator, because it doesn't matter what happens next, you're doomed. All right, so I'm going to put it in this calculator. And I strongly recommend that you put this in a calculator to see if you get the same answer that I do. Okay. Now, because we're taking a square root, there's a very good chance that this decimal will go on forever and never repeat, that it will be an irrational number. So what do? Well, we're going to have to round at some point. For my classes, the rule of thumb is going to be round to 4 decimal places. So we're going to round this to 4 decimal places, and to 4 decimals I get 0.0062. It was actually a 1, but there was a 9 after it that caused the 1 to round up to 2. If you put this in a calculator and got to 4 decimal places, you're good. If you got something different, try it again, and if you still can't get it, please message me. Shoot, if you're just watching this in YouTube world, send me a message through YouTube. Drop a comment below and I'll guide you. I'll do whatever I have to help you with this. All right, that's the answer to number 2, standard error. The hardest part is over. I would argue the hardest part is what we just did. The second hardest part is what we did in step 1. There are 2 more steps to complete this confidence interval. Number 3, calculate the margin of error. It is a formula. Remember the variable I'm using for margin of error is capital M-E. In some books it's just a capital M. In some books it's a lowercase m, which is dumb because that means so many other things. But the formula for margin of error is simply the product of the first 2 answers. It's the z that we got times the standard error. And as we go through more confidence intervals, you'll recognize that this is how you always calculate the margin of error. You always multiply the answer to part 1 with the answer to part 2. So here it's pretty easy. The margin of error is going to be our z, which was 1.96. I was writing answers over here and I stopped writing them. Now, well, our z was 1.96. And our standard error was 0.0062. Again, I apologize for the inconsistency of sometimes putting a 0 to the left of the decimal and sometimes not. My inclination is actually to put the 0. I'll try to be more consistent. Now, as a multiplication problem, this would have 6 decimal places. But sticking with my round to 4 decimal places is necessary protocol. If you're in my class, anytime you do a calculation, if it goes beyond 4 decimals, just write your answer rounded to 4 decimals, and the answer here is 0.012. The next digit is 1, but there's a 5 after it, so it rounds that 1 up to a 2. And that's our margin of error. It's just a multiplication problem. Our last step is to create the interval. And I'll just say calculate the interval and write the formula. But at this point, you may already know how this concludes, based on what we've discussed about confidence intervals in general. Number 1, they're centered at the point estimate. In other words, they're centered at the sample version of the population value that we're estimating, so we know where it's centered. And number 2, we open it by some margin of error, and we just calculated it. But if you really want a formula, the formula for the confidence interval is p hat plus or minus the margin of error. And we have all of that information. So, p hat plus or minus the margin of error, our p hat was 0.04, plus or minus our margin of error, 0.0122, and I prefer writing the answer in the form from the answer to the subtraction problem to the answer to the addition problem. If we subtract 0.04 minus 0.012, 22, we'll get 0.0278. And if we add instead, we get 0.0522. Now, if we wanted to interpret this, it would probably be a better idea to write these in terms of percents. Percents are great for describing things, horrible for doing math with, but since we're describing the percent of all mosquitoes that had West Nile virus in East Texas, it would probably be better to turn these into percents. Don't worry, in my class, I'll let you know whether or not I want you to turn into a percent. Move the decimal 2 places to the right, and our final confidence interval is from 2.78% to 5.22%, and if you watched the previous video, that's the interval that I gave you when we talked about what it meant to be a confidence level. All right, so to summarize, if you have a percent of a sample that has a characteristic, and you know the sample size, and you know a confidence level, it is very procedural to build a confidence interval. We'll do another example in the next video, but the 4 steps will always be the same. Find the z, find the standard error, find the margin of error, and find the interval. And in fact, we could even write those steps with a lot fewer letters. Number 1, find z. Number 2, find the standard error, that's just a formula. Number 3, find the margin of error, again, that's just the formula. And number 4, find the interval. With the exception of step 1, every confidence interval that we're going to see is going to do the same steps. Gee, what could be different on step 1 instead of finding z? All right, we'll do another example in the next video. But like I said, this is very straightforward and procedural. Grab the information, do this to it, and then you got your answer.